Hey everybody, welcome back. We're going to be looking at objective managers today, specifically an implementation of the observer pattern that allows us to track progress inside of our level. We're going to start off by creating a new class, and we're going to call that class BP Objective Manager. With the BP Objective Manager in place, I'm going to go to our event graph, and we're going to describe three things that are going to happen inside of this class. So first one is we're going to initialize the quest. And then we're going to update the quest alongside progress. And then the third thing is we're going to complete the quest. So some of these things will have a very clear vision of how to do, and some of these things will take a little bit of consideration for what your project is going to need. So we're going to start off at the end with the complete quest. I'm going to create a custom event called complete quest. And what this is going to do is it's going to send out some activation to an actor in the world. So we're going to create a generic class that's going to allow other classes to be inherited from it that can be activated. So I'm going to come up and create another blueprint class called actor, and we'll call this BP activated actor. And inside of this, all we're going to do is have exactly one function, and we're going to call that activate. So with activate in place, I'm going to put a little debug in there for right now. We'll say print string. And for this, we can say I am activated. So our object manager is going to want to reach out and activate that thing, but we might want to have a series of things that get activated. Maybe you open a door and play a sound and spawn enemies, right? So we'll have this activated targets variable, and we'll choose our actor, and we'll turn this into a public variable so that the designer can add things to it. And we're just going to change this to an array so we can get multiple things in that list if necessary. So I'm going to control click drag this out here, and I'm just going to say for each, we're going to activate. And the activate is only going to be available if this is the right class. So remember that the loops are passing through a type of object. If you don't have the array being sent in properly, then the array element is going to be defined properly, and so it won't be referencing the correct class. So for complete quest, this should work for us. We're going to want to update the quest with some logic of comparing how many things they've done in contrast with how many things can be done. So we can get some information about that just by considering that there are going to be some integers here representing a count. The first count is going to be a measure of the total objects. So total objective count. And then the second one is going to be the current objective count. Now they're going to both start off at 0 when we compile, which is fine. We're going to look at this and make a determination as to whether or not the objective count is met when they send an update. So we're going to take both of these, get and get. So when our current total is equal to our current count is equal to our total count, then we can throw off a branch. And if it is true, then we can complete quest. And if it's not true, then we won't. So where do we get our progress if we're going to be doing this? Each time that we fire off our update, we want to make one step closer towards complete progress. So what I'll need to do is get my current objective, and rather than saying that I could set my current objective equal to something plus 1, there we go. So rather than saying set current objective equal to current objective plus 1, we have a shortcut for going up by 1, and that's called the increment function. So you can increment and decrement, and since it says a diamond here, it's passing by reference. So when I plus it, it's passing that value back into the variable to reassign it. So I don't need to worry about setting after the fact. So I'm going to increment that value each time we come in here, and then that should get us the current value when I go to do the comparison. So the question is, when does this happen? Well, we need to set up a system that will look at all the objects inside of our world that are relevant to our quest and to determine when they're going to give feedback that they should be updated. For simplicity's sake, we're going to look at an actor being destroyed, but a more complex solution might have something like the state of the thing reaches a certain level, and you create like a dispatcher or a bind. But for us, the simplicity of setting this up will be on destroy. So I'm going to use the begin play to initialize. What we're going to do is we're going to take a list of total objects that are relevant to the quest. So we're going to add a new variable, and we're going to call this quest objects, or objective objects, whatever you want to call it. Quest actors would be fine. When I do this, I'm going to choose a generic actor class, and we're going to choose the public variable, and we're going to make this a array again. And so with these, I can draw out the list, and I can get length, and I can set the total objective count equal to length. So that'll be the first thing that I do. So our total objective count is going to be relevant or relative to the number of things that the designer adds to the object list. So with the quest actors, I need to also tell them that when they're done, meaning when they are destroyed, they need to notify this this object, this manager, that their part in the quest is over. So we're going to do a for each loop on this, which means that we're going to step through the array and we're going to get each of the actors, and for each of the actors, what we're going to do is bind event on destroy. So for each one of these actors that are in the list, when they are destroyed, it will fire off an event over here. And for us, this will be a custom event named update quest. So this allows the designer to set a collection of items to be interacted with and a collection of targets to have be affected by. So let's go and look at a scenario where this works. Ideally, if we've set everything up correctly, it doesn't matter what actors we have as long as they can be destroyed. I'm going to have an activated actor over here, and I'm going to have my manager over here. The manager doesn't need physical space, but it's nice to keep it near your objects. I'm going to add 3 quest actors and 1 target. For the target, I'm just going to select this guy over here, and for the quest actors, I'm just going to click these 3. So theoretically, if everything's been set up properly, when I play, I should be able to get 1, 2, and 3, and then you see that I am activated in the upper corner. So this is pretty remedial for getting the functionality in place, but we need to communicate with the player about the progress as they're going along, and we probably want the activated thing to be something a little bit more interesting. You'll notice that I have in my environment some doors from previous tutorials. If you guys have been following along those, I have the kinematic doors, which inherit from the BP a kinematic base actor. And the kinematic base actor basically just says when something happens, move 2 things between a thing between 2 pivots. And this is inherited from the actor class. What I can do is I can change the way that this class is inheriting. Rather than being from the actor class, I can choose the BP activated actor, and since that came from actor, I haven't lost anything. I've just added the ability to say activate. So I can have the activate will come over here. We'll say override activate. This comes from BP actor, and so whenever activate occurs, then I can just play the function. So now any door that I want to point to can reference this functionality. Just because I've created a nice hierarchical chain that things can be activated. I have kinematic objects. Kinematic objects can be activated, and I have a door that's a kinematic object that can be activated. And so now I can reference this specific door, and I don't need to do anything to get it to work with my objective system. I can just take this kinematic door, and then for my quest, I'll have the quest target that I have there, and I'll add another one. And we'll just select the door. So here the player will now be notified that the door is opened. And of course, I could always just unlock that rather than opening it if that's the behavior that I wanted to do. But we still have to notify the player about what's going on inside the world. So to go to our quest trigger, our quest objective manager, when we initialize the quest and when we update the quest, what we probably want to do is send text out to the to the HUD. And so we have a class to be able to set up to do that. So the class that we would use, or the object that we would use, is the update objective text. So this will send information out to the HUD. We're going to put this into its own function right now because we want to update quest text multiple times. I don't want to have to copy this text multiple times. So we're going to create a new function, and we're going to call this update HUD. And we're going to end this update objective text. And in here, we're going to grab a few things. We're going to mess with a few other elements inside of Unreal today. For the duration, we can just set the brief duration of 3 seconds to have something flash up on screen. And for our objective text, we're going to format text. This is going to give us the ability to pass in a few variables and have those structured in a specific format. And for the target for this, if you can recall, we need to get the player controller, and then from there, get the HUD. And since that HUD implements our interface from previous tutorial, we'll be able to send this off no problem. So for the format text, anything you put inside of curly brackets becomes a variable. So I'm going to have a few variables to address. We're going to have the object type. We're going to have the current count, and then we're going to have the total, and then we're going to have the things. So this is going to allow us to create a sentence that'll say, do something X of Y things. So kill 3 of 7 enemies, right? We've done so many of those things. So for the current, for the total, it should be fairly straightforward. We're going to take the total objective count and run that in here. Now the current count is counting up, and what I want here is for this to count down. And we want to count down as a value of the total count minus the current count. So if I've only done 1 of the objectives, then I want this to say 6 of 7. If I've done 3 of the objectives, then I want it to say, 1 of 4, right? So this is going to get us our current value is the remaining. And in fact, we could probably just change it to remaining to be a little bit more clear. And then since this goes in order, we can just refresh the node, and that'll put it in the right order. All right, for our object type, we want to clarify the way that we can control this dynamically so that this manager doesn't need to be edited to a major extent each time, where we're not just pulling in text and you're typing that in, but we have certain quest types. So we're going to go into our utility section, and we're going to create a new type of asset. We're going to create a enumeration. And so an enumeration is really just a named ordered list. So we're going to call this quest types. So I'm going to add a few quests here. We'll call the first one collect, and we'll see defeat, and then maybe there's like a visit, right? So go to locations. So as we do this, then I have these quest types. When I create this enumerator, I use e underscore as the designation for it. This is now available to my entire project as a data type. So if I go to my objective manager, I can come over here and create a new variable. I'll say quest type, and what we're going to do is choose this. We'll do e quest type, and we're going to expose this and change it from a array to a single. And you can see over here I have collect, defeat, and visit. And what I can do is take this over into my list here, and we can say to text, and this will give me the text value of that thing. And so now I can start to get a representation of how many of those things need to happen, or what type of thing needs to happen. And then for the things, we can, promote. We'll just do a variable for now, but a more robust version may have you build a component that gets attached to an object if it's a quest object, and then it has an attribute called quest object type, and then you could pull that in here and get it dynamically. But we'll just do a thing name, and we'll call this text and expose that out, and we'll just put it in here. So thing name for the device manager. So Now I should be able to look at my manager here. I have my quest actors. The quest type is collect, and the thing name is, we'll say, buckets. And so now I need to push that out to the screen. So with this text, it's being prepared to be sent out. So we're going to update the HUD here. And then anytime that we don't complete this, we have update HUD. It'll give us the progress. And then if we do have this complete, then what we can do is take this chunk of text here and maybe have a variable that says like quest complete text, or you could leave this to be the text that gets notified on the initialization of some other object. So here, you did it. All right. So let's go in, collect 3 of 3 buckets, 2, 3. You did it, and the door opens. Alternatively, I could come back into my level, and I could take this bucket and this bucket as clones. And now when I select this, I want to just add a few more things. And now collect 5 of 5 buckets. And I could change this out a little bit more to say that I have the quest object, the objective manager. I could change this from an actor to an activated type. And then instead of event begin play, right, I could do an override on activated or activate and say we're going to do this as our first quest. And then this would be on a branch. Getting a little compact. So for that branch, we just promote this to a variable called, quest available on startup. I don't know, quest, we'll say available on start. So by default, this value will be set to false for us because we don't want all the quests to be available on start. So if available on start is true, then it will run this, and if it isn't, then it'll wait for the activate to run the initialization. And so I can chain these together, where if I have a new object manager, then let's set the door over here. This object manager, let's see here, we'll take the 2 that we just added in here. We'll remove these from the end of the list, bucket 7 and 8. And then this manager, let's see, this one is still referencing that. Okay, so we'll take this manager here. We'll add 2 quest actors, 1 and 2. And then I'm going to choose a target to unlock, which will be this door. And we'll remove the door from this one. So our activated targets is not going to include the door, and we're not going to include that other actor. What we are going to do is target this object manager. So I have a manager that's going to fire a manager, and then that should activate the door. So let's see if we have this correct thing name. We'll say buckets again for this one. So it's not activated initially, so we're going to come back here. For this one, we're going to say available on start. I got 3 buckets. I collect them. It says I did it. The new quest is up there. And then I have the 2 buckets that says you did it. And the door opens for us. So this is a way for us to create a manager that will allow us to chain events together, to look at multiple objects in a remedial fashion of destroying them or collecting them. And of course, this logic can always be extended out to allow you to customize it for your project. If you have questions, throw them at me, but this will hopefully let you go out there and keep building.